Okay, we're going to start. If you agree. Hello, everyone. Welcome to the keynote lecture of EmTech final Master of Architecture presentations. For those of you who are joining us online as well, we're very happy to have Wolf Mangelsdorf here with us. Wolf has been a very good friend of EmTech for a long time. He is partner in Buro Happold Engineering and the head of Future Ready Department and global head of innovation, technology, and design. Wolf also, since 2021, is a professor of structure in the Angewandte Institute of Architecture. Without any further ado, welcome Wolf here. Thank you for being here.
Thank you. Yeah, thanks for inviting me, and thanks to see you. Yeah, great to see you here in the room. And I don't know how many people we have online. We won't know, and keep your cameras off. Yeah. I'm going to talk to you about climate change tonight. Yeah, it's an obvious kind of thing, but I'm going to look at this through the perspective of me as a structural engineer, me as a teacher in structural engineering, but actually also my outlook on what are the big trends in the future. That is what I do as part of our global leadership team in my firm, looking at what's happening, what do we need to be prepared for not this year or in 5 years' time, but in 25 years or 15 years, looking at what are these big trends that will determine where the world is going. And it goes sort of right back to conversations that I've been having with Mike for years, yeah? Your book about climate and urban development and, all these kinds of, all look at these, how do these big trends in the end influence where we're going, what we're doing. So a little bit about me. You said a lot of it already. Thank you for the introduction. This is me. I'm a partner at Buro Happold, and I'm a professor of structural design at the Angewandte in Vienna. It's a very small, very nice architecture school. Yeah, 120 students, roughly 3 design studios, and I'm having a lot of fun there. My firm, you may have heard about. Yeah, we're a big engineering and advisory firm, global firm now. Yeah, we come out of Bath, basically. Yeah, Ted Happold, the founder of our firm, was a professor of structural design, I think, or integrated design at Bath University, and then at some point took his entire team from Arab with him and founded Buro Happold. So we actually come out of sort of one of those 5 UK offices in Somerset, but then from there went into the world with literally all the big architects that we have been working with and the big clients. We have a big presence in Saudi Arabia, I should say. All our early work goes back in the 1970s with Frei Otto in Saudi Arabia, so we have a long-standing kind of history there. At the moment, that is actually quite good, yeah, because we know all those who are in key positions out there really well. That country has been quite influential and important to us, I should say, yeah. But that's not the only place in the world where we build, yeah. We've left our footprint all over London. I've got a few pictures here, yeah. All over London, the British Museum over there, the Olympic Stadium, the Millennium Dome, and a few others, yeah. We've done pretty much every stadium here, yeah, Arsenal, Tottenham, yeah, for those who are interested in that sort of stuff. And since some of those projects have also been mine, yeah, I've been, as a structural engineer, working on the super complex stuff, many years with Zaha Hadid and her team all over the world. Yeah, you can see here sort of Morpheus and other things, but a broad spectrum of things that have sort of kept me always quite at the forefront of what's happening in engineering and where we're working with our clients and what's sort of working and what's sort of not working. But what I really want to talk about, and that was just really to position myself in this and position our firm in this, what I really want to talk about is this whole kind of big theme of climate emergency, climate change. And like all big design firms, you will have come across this across the world. Yeah, we have our own targets around carbon emissions and sustainability. And our targets, you can see that here, 2030, all our projects to be net zero carbon. The interesting part here is also the net in the zero carbon. But then the right-hand side, interesting here, 50% of the embodied energy compared to baseline, because we do have a problem. And that problem in our industry, massively so, is materials. Materials, if you look at that, materials have embodied carbon and emissions throughout their entire life. Yeah, we class this into these different steps, A, 1 to 5, B, C, and then the rest again, the recycling in the end if it happens. But at every stage, there are carbon emissions, and those carbon emissions are substantial. If you look at greenhouse gas emissions, to be more precise, in our sector, that's almost 40%. Building and using buildings, and I'm telling you nothing that you don't know yet. Yeah? You have heard this all before, I'm pretty sure. And if you then split this further, the big part here, 11, 12, 13%, numbers vary, are actually just materials and construction. So whatever we do has an enormous impact on the carbon balance or the greenhouse gas balance that we have. And over time, this has shifted. Over time, because we are able to reduce emissions in the running of our building through electrification, through green energy, and efficiency also in how we design our buildings for better operation. That relationship, you can see that here, that relationship between embodied carbon or embodied greenhouse gas emissions and operational greenhouse gas emissions is shifting ever further towards, actually nothing's really changing in the embodied while the rest is shrinking away. And that is to do with the materials that we primarily build with. This is sort of baseline kind of idea of what the greenhouse gas emissions for different materials are. I have this, I forgot about that. And those are quite dramatic. These are measured in kilograms of CO2 equivalent per kilogram of building material, right? If you look at aluminium, freshly produced, 11 kilograms per kilogram is quite substantial, right? But if you look at does this work? No, it doesn't. Forget about it. If you look at just the standard materials we use all the time, steel, 3.7, concrete, cement, big number as well. But even timber is not, and I will show that in a moment, is not a zero carbon material. And so whatever we do, we have that problem of our materials being big carbon emitters. You've probably seen this, yeah? Most of it is to do with chemistry, not so much to do with energy. So in the production of cement, we blast carbon dioxide out of limestone, and that gives us cement. Very simple terms. That happens at 1400 degrees, thereabouts, so not something that you can easily do with electric heating, so you have to gas fire it. And what you get out of this is the cement industry across the world is about 8% of global carbon emissions. Big chunk. But then cement as a material has been around 4 centuries, yeah? It goes back to this here, yeah, concrete construction has its beginnings in the Pantheon in Rome, but then really took off at the beginning of the 20th century. This is sort of Hennebig's structures in reinforced concrete, an entire typology, entire tectonic logic developing out of concrete. And in a way, an absolutely fantastic material out of which you can do or build things that were previously not possible. And some masters of the use of that material emerged, like Robert Maillard, who knew exactly where to place material to get the optimum performance out of his bridges, and the aesthetics of those bridges matched their structural performance. And with that, a whole new aesthetic kind of develops. Similarly, the structures of Heinz Isler or the Saarinen terminal, TWA terminal in New York. An entire aesthetic that was not possible before. Developing out of a material that is new and sparks off, I think that's my point here, an architectural quest for new form, creativity, and a look into a future of architecture that is quite different from what was there before. Needless to say that actually the primary use of concrete is this, enormous amounts just going into slabs being stacked, and that is the sort of big issue, right? Huge volumes everywhere in the world. We have a similar story with iron and steel, because there again, it's primarily a chemical issue. The chemistry of making iron is ripping oxygen out of ferrous oxide, and that is best done with carbon monoxide. And you take that carbon monoxide and you let it react with the iron ore, and what you get is raw iron. In very, very simplistic terms. I'm not going to bore you with all the intricacies of the chemistry here, but that process needs a lot of heat and a lot of coal. There's some hope though, because you can make this process work with hydrogen. You could potentially, and there's tests that are running with this, you can do that reaction, the reduction reaction, where you get the oxygen out of the ferrous oxide. You can do this with highly reactive hydrogen. But then that only works properly if that hydrogen is done in a sustainable manner. Because hydrogen, as we can buy it normally, is just taken from methane, where you take the CO2 out and you're left with the hydrogen, so you're not really getting anywhere. And in all of this, the story very similar. Steel, that's obviously not just construction. Cement is primarily construction, is equally about 8% of global carbon emissions. But a similar story here, that out of steel, out of the invention and the research into the use of a new material, an entirely new architecture, an entirely new opportunity to build bigger, to build more ambitiously developed, which is quite fascinating. Here, 19th century, Frankfurt Station, or the extremely delicate structures of Mies van der Rohe's Lakeshore Drive apartments, or one of ours here down the road, the Millennium Dome. Perfect example of what you can do if you master using a material. This is entirely built from steel, with the exception of the membrane, which is a glass fiber material. Or then this, one of mine, Zaha Hadid's Glasgow Riverside Museum. We use steel to create the most unbelievable form, because it is a fantastic material for this kind of thing. But then it comes at that cost that I just mentioned. Similarly, this, another one of mine, KFD metro station, opened last year. That's what it looks like. That's how you create this form. And we need to ask ourselves, is this where it should go? Is this the way to use what I would say is a precious material? Because precious, not because it's so expensive in money terms, but precious because it's so expensive in emission terms. And again, similar to concrete, another one of mine here is steelwork is used primarily to put floor plates one on top of the other. Yeah? Big spans possible with steelwork beams. We see that everywhere in the city. This was an interesting one, that project that I just showed you, because we did, that was 2010 or something. Don't know if I have the number, 12, yeah. We did that's when it was completed, yeah. But in the run-up to this thing, between 2009 and 2012, we did a full carbon life cycle assessment. I had a guy in my office who had an absolute passion for this. He dug into all the early all the early databases that he could find, getting these numbers that are now widely published everywhere, and did all this meticulously. British Land, the client that we worked with at the time, paid for us. We were showed great foresight with this. And then as the project was complete, I went to see their sustainability director and asked her whether we shouldn't do this on all projects, because we could actually demonstrate we could save some embodied carbon through clever interventions, the right design of the foundations or the right cladding material and so forth. And she said to me that was a bit of a non-story. No one's interested. Why would we do that? Well, fast forward 15, 20 years, yeah, and it is just a story. It's everywhere. And in timber, I need to put in there as well as a material. I said it's not zero carbon, because even though timber is made from trees grow by taking carbon out of the air and turning it into the material that is timber, the fibrous material that is timber in the end. What we're doing with it isn't really taking the tree and making it into a building. We're turning it into an industrial product. There's an enormous amount of cutting, drying, kiln drying, preparing, gluing, and turning it into what is ultimately an industrial building material that has its own carbon impact. Much lower than steel or concrete, but still not the sort of zero carbon wonder material. And even with timber as an industrial material, I should say, fantastic architectural and structural forms emerged. This is one of those that really fascinates me. We were just talking about timber grid shells on the way over, because I went to a conference not so long ago, and there was lots of work being shown about tiny little timber grid shells, and I said, have a look at those. Yeah, we built them years ago. Fascinating structures. But as you can see from this project here, in most cases, we turn, as I said, timber into industrial building products. They are glue-laminated sections that are then connected with steelwork connectors or something similar that create their own aesthetic, create their own architectural expression, but are highly technical. And then the quest to turn timber similar to steel and concrete into a material that is easy to use for the development of multi-story buildings. Yeah, this one is a fascinating one. It's now a few years old, but it literally using glue-laminated, cross-laminated timber as it's not one of ours, it's Fast & Epps, structural engineers for this, turning that into a material that can produce flat slabs, yeah? That is where we want to land, flat slabs on columns. And a recent one where timber is then taken to the sort of end game, basically. Yeah? Make it as big as you can. Well, pardon the pun, yeah, it's with big architects, yeah? It is the new Dock A of Zurich Airport, enormous timber structure. Entire building sits on a concrete plinth, but is then made from big laminated timber elements. This project that we worked on in Pittsburgh in Philadelphia, is one where we studied that in quite some detail. What are the different carbon outcomes when you compare different material systems? And you can see it here. This is just purely the embodied carbon per square meter of the structure, not the entire building, I should say, yeah, because so that you don't get confused with other numbers that I will show you in a moment, yeah. There's a 50% reduction from the concrete option to the timber option, but as I said, it's not zero, yeah. And that is where the whole kind of story lands. I get there in a moment. But before we do, I think there's another thing that we need to this is a study that one of my colleagues did, that we need to be absolutely mindful if we build with timber, because it's the end of life. That is critical here. If at the end of life we throw the timber into the landfill, then anything that has been sequestered, all the carbon that has been pulled out of the air, is going to be put back into the atmosphere. And so timber can actually become quite a carbon-intensive material if we don't look at the entire life cycle, which is then a design challenge, because we don't want to throw our buildings away after 30 years or 50 years or whenever it is we need to. This one here has been around for a while, yeah? But 5 Broadgate that I showed you earlier, yeah, the one where we did the embodied carbon analysis, for which we actually won a sustainability prize, it replaced 2 perfectly good buildings. They were just a little too small, yeah. So yes, here you can see how if you get it wrong, it's worse than building with concrete. And then one of those areas that I'm looking at with my students, what are the alternatives? Yeah? Can we build with rammed earth? Can we actually do something that is as ambitious architecturally and as ambitious structurally if we build with rammed earth or if we build with mushrooms? Yeah. Not quite, yeah. We're not quite there yet. And that is where I'm saying we have a big problem. So we need to rethink how we design and how we build and what we build. Everyone in our industry is talking about a whole life carbon vision. This is the UK Green Building Council. Everybody knows that this is a problem that we need to be engaging with. A whole lot of targets have been set, a whole lot of ideas have been set, and the key to it, so we believe, seems to be working in a circular economy, working with circularity, ensuring that we reuse our buildings, that we don't do what I just mentioned in the timber buildings that we throw away at the end of the life of a building, that what we have put into the building. Otherwise, we will never get out of this. That means we need to design for adaptability. There's a big challenge around that, yeah? Do we design something that is purpose-made for the use that we are designing it for now? Or are we using buildings in different ways over their lifespan? Can we adapt them to different usages? And if so, what does that mean? Yeah, this is a study that I did many years ago for Sidewalk Labs, looking at what are the geometrical constraints. It's mainly about floor-to-ceiling heights, mainly about the space that you give to the user. And if it's residential, you can get away with 2.5 meters floor-to-ceiling. If you do an office building, you don't. So where's the sweet spot? Yeah, do you start building residential buildings with 3.5 meters floor to ceiling so you can transform them? Yeah, which way do you want to transform them? How do you get this, what I call loose fit into the building that then allows you to do this kind of transformation strategy that can happen throughout the life of a building? Some of the buildings that we are inhabiting now here, yeah, they've been around for 250 years or something, and been quite flexible in how we can reuse them, but in many ways also extremely constrained. Yeah, if any of my client would see that I put a floor plan down for their new office buildings, which looks like this, or I've designed a lecture theatre for a university somewhere that looks like this, I would be thrown out, right? So where do the limits of all of this sit? In London, this has become the norm now, that we look at what do we do with existing buildings, what do we do with the transformation, or we call it adaptive reuse of existing buildings. This is JP Morgan's headquarters here. It's not quite as big as the one in New York, right? In Gresham Street in the city. And what we did here is we took the existing frame of a 1960s buildings and added 40% floor area. Without having to build in new foundations, we had to do some trickery in the foundations, but not having to build in new piles or anything. And I think this is a video. Yeah, we were able to do this in studies that allow us to offset loadings, to ensure that we understand exactly what the material capacities are, and then build as much as possible on top of an existing structure. We do this everywhere. We reuse materials, and the London boroughs are actually looking at us prioritizing reuse and adaptive reuse over the demolition and new build, even if at times that doesn't make sense. Yeah, there are examples where you're probably better off, even from a carbon point of view, if you demolish and rebuild, but there's a very good number of buildings where it makes absolute sense to do this. But here's sort of how this plays out in numbers. If we look at a standard building in London, 6 to 8 stories now being built anywhere, we look about round numbers, 1,000 kilograms of embodied carbon per square meter. This is a round number. Yeah, some people say it's 850. Others, when you don't really look at the number, it's 1,200. So let's settle for a ton per square meter, and that's sort of easy to see. The targets that people have set themselves, London boroughs or land securities, one of the big developers here in London, they sit at 500 for 2030, right? 5 years from now. That's a steep target because, as you've seen, we don't quite know how to get there. And at the same time, half a ton is not zero, right? So we're still nowhere near where we actually need to be. So a whole lot of work is going on, and we're quite connected to this, of researching what can happen with materials, how we can take materials forward, zero concrete, zero steel. I mentioned some of those options already, producing iron, using hydrogen, replacing cement with fly ash or with other. Actually, fly ash is a good one, because that comes actually out of the steel making process, and you only get it if you're actually making steel with coke. But that's a different story. So there's a whole load of stuff going on in the background. None of them are at a point yet where it's scalable, because I think that's the key piece. The reason why cement industry is an 8% contributor to global greenhouse gas emissions is the scale of the construction industry. It's enormous. I read somewhere that concrete is the second most used material after water or something. It's unbelievable. So any one of these kind of things, they happen and they work, but in a laboratory scale or on a small scale, no one's yet moved that up to the next level, right? Similarly with decarbonization of steel, a whole lot of progress has been made in electric arc furnaces. They're only there to make steel, not to make iron. So only for that last bit of the process, to take iron and make steel out of it, or to remelt steel that is recycled. But if you then look at the projections of construction material use in the world, it's not really going down, it's going up. So the projection of concrete use, that scale issue, is only growing. And it's shifting geographically, and I'm going to come to that in a moment. And more interesting, a lot of the decarbonization is a bet on what I'm showing there in blue. Yeah, this is from Holcim, one of the big cement producers. They're betting on the majority of the carbon tech being taken out of cement making through carbon capture and storage. That means you suck it out and you put it somewhere underground. Government is currently pledging billions for that. It's not a scalable alternative yet. And does it really make sense? We'll see. But you can see that big dip happens after 2030, so we keep business as usual, and then we move forward and we decarbonize with carbon capture and storage. I don't believe that story. I just don't believe it, yeah? And that's why I'm getting to the, have we got this right? Because in the background, we have another problem. And I've already alluded to that sort of a little bit, yeah? We're not done yet, yeah? We're 8 billion people, and by 2050, we will be 10 billion. 10 billion, the difference is 2 billion people. That is 200 times London to house them. That is massive. And that's not going to happen in London, or it's not going to happen, well, somebody said the other day, it might happen in Yorkshire because of climate migration. But yeah, let's see whether Sheffield is going to grow to that sort of size. But it is about having to build housing, or basically cities, for another 2 billion people, for another 25% of the current population. That doesn't really help with the problem, yeah? And if you then see that this growth isn't happening in the places of the planet that we have in a sort of equally distributed way, but actually you have population shrinkage in places like North America and China and Europe, but massive growth in Southeast Asia and in Africa, you can see that we can't actually assume that we adaptive reuse ourselves out of the carbon crisis, yeah? There you go. That's where the population growth is projected between 2016 and 2050, and you see how various different countries slip up in the league table here, yeah? Particularly sort of Nigeria, Indonesia. Look at the numbers, enormous, yeah? Doubling in size. And so if you look at Lagos, Nigeria, that's what this looks like. That isn't sort of put 40% extra on the existing steel frame from the 1960s and you will get the right answer, yeah? There was some studies done by the Washington Post not long ago that I kind of quote here again. That's the sort of 2015 population density, estimated population, you don't quite know, 15 million. You take that and project this to 2100 and you get to 80 to 100 million people in one city. And that is just one. If you look across the world, you get similar size cities in Indonesia, you get similar size cities in other parts of Southeast Asia. The point here is, this is going to happen, yeah? It doesn't, if we believe that we can decarbonize ourselves out of the mess by adaptive reuse or not building anymore at all, I hear that quite a lot, then I think we're on the wrong path. And we're just closing our eyes to a problem that is much bigger than we think it is. But I was at a conference once with a woman from Switzerland, and she contradicted me. She said, it's not my problem because I live in Switzerland. And I thought that was very interesting. Yeah, that was the sort of, I close my eyes because it's happening in Nigeria or in other places that I don't see. Back to that. And then we have a further problem. Because that whole 1.5 degree limit that was set, when was that? Some COP in Paris, yeah? Many COPs since then, yeah? We've done it, right? We're there. That is not a target that we can achieve because we've already passed it, more or less, yeah? Last year, I read that the other day, it wasn't 1.5, it was 1.47 or something, yeah? In my book, that's 1.5. And that's the pictures that we get on a daily basis. That was the biggest hurricane in a century, I think, yeah? Melissa out in Jamaica, droughts in Europe, wildfires, we're sort of used to that. But those are interesting pictures here because what's happening here is that you get a little bit of a financial crisis growing here too, because large swathes of buildings, houses, dwellings, whatever, in those places where this happens, they're uninsurable. They aren't being insured anymore. And if they're not insured anymore, if they're uninsurable, they're unmortgageable, and therefore they have no value. So a huge crisis storing up in that's just a sort of sideline. And then the final thing, obvious, yeah, you all know about this, we all live in coastal areas, more or less, yeah. The majority of our big urban conurbations or urban metropolitan areas are coastal cities. And we sort of think, yeah, it's going to happen somewhere in Jakarta, yeah? Jakarta is actually being moved. So the Indonesian government is actually trying to move this capital somewhere else because Jakarta is at such risk of flooding that they want to prevent this or preempt this. Manila, Bangkok, Dubai. But that's London, yeah? So London looks pretty bad here too, yeah? If the predictions for the sea level rise that we get out of this are anywhere near true, yeah? So is New York. So can we design ourselves to zero carbon? I totally doubt it. I think we need to completely rethink. And then I looked at the net and had a Google into what does climate resilient architect look like? And you get this sort of stuff. You get, that's everywhere, right? Stefano Boeri, love him, nice guy, right? His Bosco Verticale. Really? Yeah? You stick trees onto and that's climate resilience? But that's the pictures that you get, yeah? And I Googled that yesterday, yeah? So it's not something that has changed massively. I compared it with the last time I did a similar lecture in this room, and the pictures still look the same. So we haven't moved on at all either. So really, yeah, is this the answer? I doubt it, yeah? Or is this the answer, yeah? I think they've answered it themselves, right? So I think this has sort of shrunk itself into something disappearing. Or is this the answer? That's a project that we did with years ago, a big dam built all around Manhattan. Or is it ultimately that? And that's where you guys come in, yeah? Because we need to reinvent architecture. We need to reinvent what we build and how we build. We need to reinvent what we do with what we have and where we take this so that we can create a livable future for us as a species on this planet. The planet doesn't care, right? So the planet will sort of scratch an itch, right? It's going to be sort of bad for a while, but give it 2 million years and it'll recover, and it's all going to... So it's not about the planet at all. It's about us. It's about humans on that planet, on this planet. And we as architects and designers and engineers have an enormous challenge, an enormous responsibility, but I think at the same time also something that is somewhat quite fascinating, yeah? Because we are at that point where we have to reinvent it. So, how can I say? Good luck, have fun, enjoy it. I'm happy to be part of that journey as long as I can, but we have to completely rethink. Thank you.
Thank you both for this amazing lecture. Now we have some time for the audience. If any questions from the audience, by a raise of hand. Sure.
Go on, don't be shy.
Thank you, Wolf. This was really, really nice and very interesting, especially because you are deconstructing some kind of assumptions that I think we all kind of think about, and it was really nice to hear. Maybe we need to find another way. I was thinking of the buildings that you showed, the Zaha buildings, and of that moment, no? Because in a way you're saying we're in that moment again, and you were designing those structures that were extremely complex, and you had to develop all the, even the softwares to develop those structures and how to bypass the technical problem, no? Mm-hmm. And that excitement that was to develop those buildings, I feel like that's kind of what you're calling for, like to generate an excitement to design for these new types of buildings and then solve them. But my question is, at that time, those buildings were extremely expensive anyways, no? So financially were an effort, so they didn't make much sense, not only now because of carbon, but not back then because of financial questions, but there was a belief in those constructions. How would you approach the same thing now? Because somehow these scenarios of sea level rise cannot, how can I say, they can be predicted, but until they arrive, they are disasters, right? So it's completely different take. Like it's like solving a problem. So the other side of the equation is that we are solving problems. At that time, we were not solving problems. We were imagining types of spaces. So how would you say the game can actually click? Because financially, to design for something that you cannot even foresee, you know, like you cannot even see how it's going to happen, it's extremely difficult, right? I'm kind of taking your tone of pragmatism. It's not something I would ask in general, but how do you think this type of project that maybe doesn't have a ground, no, yet, that has to work on a prediction, how would you?
I think the answer is, yeah, I mean, the question is fantastic, yeah, because you have 3 layers in that question, right? The first, I thank you that you see that it has arrived in the way I wanted it to arrive. This is a challenge, but we need to see this challenge in a positive way. And reinvent architecture, reinvent infrastructure in a way that creates livable environments within the constraints of what I showed. And that's not, yeah, it's a bit of a doom and gloom message that sits behind it, but at the same time, you quite rightly identified when I was doing these kind of structures with Zaha's, wow, I had so much fun, yeah? I mean, this is structural engineers extreme sports, yeah? And yay, yeah, how far can I mean, on City of Dreams, the thing in Macau, the client came to me in the end and said, oh, my biggest nightmare was you come to me one day and say, it can't be done. The physics don't allow it to be done. That's the biggest compliment he could make me, yeah? I mean, fantastic. But you're absolutely right. It was expensive in every way. But can we find that same enthusiasm, ambition, for what the real problems are that we're talking about here. Now, you mentioned something that I think will gradually shift. Yeah, it's yes, there is a risk that, particularly with sea level rise, that it's a prediction. I don't see it because you can't measure it. Yeah, it's been maybe 20 millimeters or something. Yeah, do I care? But now certain effects are coming into the whole story that we didn't think about before. I mentioned this wildfires business. Yeah, entire areas in California are uninsurable, and literally uninsurable, and therefore unmortgageable, and therefore without value. That starts shifting perception. That starts shifting approach, because, as you quite rightly say, building is expensive at every level. Yeah, at any level. So the investments that we make into buildings, we want to have a return, and we want to have the ability to not be sitting on something which eventually is of zero value. Yeah, we don't want that. So when these kind of things start happening, then it becomes a realization. And I think we have this here with flooding. We have this with wildfires. We have it with hurricanes. So that shift is happening. I don't think it will. Yeah, there will be certain aspects, particularly sort of sea level rise. If we don't see them straight away, yeah, then maybe we push them out and say, yeah, come on, it's not a problem. But I do feel that shift is already manifesting itself. But ultimately, you're absolutely right. If it's because it is about investment, it is about putting money into those developments, finances will drive that. Money will drive it. And values. What do we value in all of this?
Anyone else? Maybe I can say something. I want to pull out one of the things you just said towards the end of the presentation. That says it's not about the planet, it's about us, which was very, I think, true and interesting. And just want to know your opinion about maybe this change of perception should be happening in like a very fundamental layers of us as a species who are living here, not just only construction, building, design, and architecture, or like everything else that comes with the values.
Yeah, I do think that we still have this perspective of there are two things that play, and I have to ad-lib this a little bit because I don't have the right answer, I don't think. Yeah, but there are two things that come to mind here. One is that what we don't see, we don't really value or estimate. Yeah, we talk about biodiversity loss. I don't see it in my garden. Yeah, Hyde Park still Hyde Park. Yeah, what are you talking about? Yeah, I've got food on the table. So, is it real, or is it? How do we measure this, right? So long as we don't feel it, we probably don't give it that much attention. But then on the flip side of that, we talk about it as if it is the poor planet that we need to worry about. Yeah, of course, yeah, we're destroying our ecosystems. But as I said, give it a couple of million years and they will recover. That's not a problem. And maybe something better comes out of it as well, right? So who knows, yeah? That's how evolution works. Certain things die and others live and things develop further. But the time spans are not human time spans, yeah? A generation is 25 years, yeah? For the planet, it's done, over, yeah? I mean, if you look at how long humanity has been around, in planetary time frames, that's a second, yeah? It's nothing. So, two things, as I said, need to happen. One is, if you're honest about it, this is purely about the preservation of us as a species. if these ecosystems don't work anymore, if we don't have, I don't know, pollinate, whatever, yeah, any of this, yeah, done, yeah, bye. And at the same time, we need to see problems and perceive them as real, even if they don't hurt us yet. I think that's where a lot of this, yeah, Uncle Donald, right? He's sort of telling us it's a hoax, right? Fine, yeah, but he's got another 4 years on this planet, yeah, if you're unlucky, and he's old, yeah. He doesn't think in those kind of terms.
Hello, thank you for the presentation. I just have one question that other than embodied carbon, what else do you think we should look at in terms of understanding this, working towards climate change in the field of engineering?
Look, I think we need to put our efforts into reducing embodied carbon, but it will not solve anything in the bigger picture. Yeah, long term, yes, good, but for the next 50 years, the challenges lie completely elsewhere. The challenges lie in creating livable environments for a growing population with all the challenges that I showed, yeah, we're talking about 200, 300 million people being displaced from coastal areas if this comes to pass, as it were, yeah? And I would put the focus on what I just call livability, yeah? On those kind of aspects that make our environments, our urban, our built environments, places where we as humans want to be. That's going to be the biggest challenge, I think. And that builds in the resiliency piece around temperature resilience and flooding and hurricanes and all of that, because that's not going to go away. Does that answer your question?
Yeah, I was just wondering, other than embodied carbon, what else do we always what are the other challenges? But yeah,
I think the challenge is a design challenge. It's not a material. There is the material challenge. Let's assume, or let's put that to one side. It is there, yeah, and we need to deal with it. But beyond that sits a design challenge that is the design of our infrastructure, of our buildings, of our built environment. It's not a. What I want to try and say is I want to lift this out of this kind of numbers and carbon kind of circle that is a bit of a closed circle that is also very quickly getting into a direction of, oh, I've done a building that's only 500 kilograms per square meter. I've solved the problem. No, you haven't. Towards something that looks at the bigger picture, that looks at it. This is a systemic issue on a number of levels that are new to us, yeah, because everything that we do in design is always systemic, yeah. We need to look at systems, otherwise we don't go anywhere. But here, a whole load of parameters that are not familiar, that are different, yeah, they come into play, and that's the big challenge.
Thank you.
Hi. I wanted to know if there were any material developments, any new material development you're looking at for your future projects and your future projects that you've not yet or possibly inculcated or incorporated in your designs.
There's a whole lot of stuff, yeah. I showed all these pictures of the various different developments of new materials that are happening there. We're not material science, we're engineers, yeah. So we can only be in a guiding function and in a function of specifying these materials and seeing what we can do in design terms to make things better in that way. We have a project in Baker Street where we're demolishing an existing building. We're cutting the slabs and putting them into the raft foundation, yeah. It's a system called PREX. We are basically using, I don't know, 1,500 cubic meters of existing concrete as structural fill material in the ground, which then forms the foundation of the new building. Yeah, so we're maxing out on all of this. We're going every avenue from new materials to adaptive reuse to intelligent reuse of existing and. But I tell you, we're not solving the problem with that, right? Maybe at some point we get to a zero carbon concrete or a replacement of concrete at scale. Yeah, scale always being the issue. And when I say scale, not only scale in mass terms, but also scale in price terms, because concrete is phenomenally cheap. And you can make it anywhere. You just need a bit of limestone somewhere, and you can make concrete. I'm not really answering your question, I think, but we're very close to all of this, and we're following it, we're supporting it, we're working with these material developers wherever we can. But I do still think, coming back to the previous question, that this is only a part of it. Yeah, there is, in the whole system of what I showed here, so many layers, from resiliency of what's happening all the way to migration, to the effects on coastal area, any of what I just showed here that need to be taken into consideration. I don't want this to be simply reduced to an embodied carbon problem. I want to lift it from there into, and that's your challenge, right? That's over to you here, yeah? Into an architectural challenge, into a design challenge that is much bigger than going to your engineer and saying, could you please put some cement replacement into my slabs, yeah?
Thank you.
Any other questions? Ah, good. More.
Thanks for the great presentation. My question is about one of your diagram about global map, where India and Southeast America and some developing country is kind of having more population than developed country, where we expect that more construction will happen. And normally, as we know, they are a little bit out of control in terms of planning and material use and in terms of design. And do you have any, as your architect, a perspective how we gonna deal with it? I mean, I went to the Vietnam and Indonesia and Malaysia, and I saw a lot of construction is happening, and most of them are built by concrete, as you know, and they demolish like within 5 or 10 years, and build again because labor is very cheap and concrete is very cheap as well. And for me, I mean, after I've been seeing all these sites. The way we deal with the material and adaptability is only applied to the developed country like UK and Japan and all America. But if we consider next 10 years, we already know that this new emerging country is building more. And as your Buro Happold partner, I think you have a certain perspective. So just wondering your kind of perspective or opinion about that.
I do have a perspective here, yeah. And there is my perspective, and then there is a wider perspective. Let me put it this way, yeah. When I say my perspective, is my perspective as a partner in an engineering company that primarily deals in developed countries, yeah, or works in developed countries. There's expertise that we have. There is knowledge that we have around urban planning, around architecture, around lean engineering that we've demonstrated wherever we go. I think we have an obligation potentially or a possibility, which way that goes, let's see, to bring that expertise to bear in countries that are rapidly developing, so that mistakes that were made in those countries that are developed, because it's not all been good, right, are not necessarily being repeated. But then if I look at the bigger perspective, how many of you are from Sheffield? Exactly, yeah? So you're not going to deal with the big growth of the Yorkshire cities because of climate migration. No, it is a joke. What I'm trying to say is you're all from these countries, yeah, more or less, yeah, from countries that are going to undergo these changes. So take this and make it your mission. Be there and be the agent of change. I think that's where we need to get to as architects and engineers, as the designers of our built environment. We need to make that our mission, because we have big responsibility in here. We're effectively putting all that concrete that is being poured into landscape onto our drawings and specifying it, and tendering it with our contractors. They happily put it everywhere, yeah? So this is my appeal to you as the next generation of architects to play an active role here and make it your mission to create these livable environments that are, and it's, as I said, yes, it's about embodied carbon, but the story that you just told, yeah, reinforces what I've been trying to say. This is a lost battle, yeah? I mean, I can do adaptive reuse in London, and that's the right thing to do. I'm not questioning that at all as much as I want, yeah? It'll be 5 times outdone by just what you described happening in Vietnam, yeah? And I don't want to look at the destruction in Syria and Gaza and all that having to be rebuilt. Enormous amount of volume, yeah? Scale, enormous. That's where this population growth is coming into the story. Because, yeah, if I have to build another 200 Londons, approximately, in order to just house the people that are going to be born between now and the extra population that's going to be on the planet between now and 2050, it's massive. Yeah. Does that answer your question? Yeah. So, make it your mission, please.
Okay, thank you so much for your presentation. And I think I get lots of the inspirations from your presentations, and there's a picture in your presentation. I think it's about quite like the towers, the modern city skyscrapers is flooded, and it looks like, yes, this picture is quite like the modern city it's a modern version of the Venice. But for the Venice city is built 100 years ago, is using different materials like the stones and the woods, using the woods as the planes and nailed down into the water. But for the modern cities, using the materials like the cements, steels, how we design as architect, how should we design the bottom part?
Look, this picture is a bit tongue-in-cheek, right? I mean, I read this of a book title, right? This is I saw this a few years ago in New York 2140, yeah? I saw this in New York in a bookshop and thought, yeah, that's the sort of provocative image, right? Mm-hmm. I'm not saying that this is now I want to make you think. I don't want to have a conversation with you about how we design foundations, yeah? I can do that for you, it's no problem, right? But it's again, the question is not a technical question. The question is one of ambition, of design direction, of dealing with complex issues in a creative manner. If that's the answer, I don't know. Maybe the answer is still that. I really do not know. But that's why I'm ending on a blank sheet with a cursor blinking, yeah? Because I don't want you to ask me how to do that. I want you to tell me how you're doing it.
Yeah, exactly. I think what I want to ask is that in your perspective, in your experience, what kind of the future, what should be like, in your perspective and experience, you can.
No, I'm telling you, I think this is my key point. Yeah, thanks, Mike. It is exactly that. I'm telling you, it is your future to shape.
Okay.
So do not come to me and ask me what the future is. Yeah, work with me and develop that future together. That's what I'm trying to say. Because it is not, because I'm the professor somewhere, I have the answer or something. No, forget it. That's not it. Yeah, this is a design challenge that is way beyond anything that we've seen before. Yeah, but there are examples in history where massive design challenges have been dealt with creativity and foresight and with the incredible outcomes out of that. Quite often, read Mike's book, yeah, to do with climate issues, yeah. Cities have come and gone because of climate issues, changing crop patterns and inability to feed the people that live there and all that, yeah. So, and quite often they're stunning, yeah. I don't know. Have you been to Angkor Wat? Go there once, yeah.
Okay, thank you. I already have the kind of the imagination in my mind to.
There you go. That's where it starts. Thank you.
Thank you.
I think this is a good one to end on, right? Unless there's more questions.
If there's no more question, just join me with a round of applause for Wolf. Thank you so much for this great and inspiring presentation. And thank you all for being here.